In this video, we will discuss a fundamental notion in data analysis, measurement scales. Let me use a pizza analogy to assist you grasp this concept. Pizza toppings include tomato sauce, cheese, and mushrooms, but the pizza probably wouldn't taste nice if you added things like chocolate or whipped cream to it. It's the same idea at work while looking at numbers. If you don't use appropriate ingredients or variables in your analytical approach, the results won't be satisfying. In mathematics, variables are just factors that can take on different values. The value German, Japanese, or South African can represent a person's nationality. Years of age are another type of variable. However, variables can be measured in a variety of ways, and it is crucial to understand the scale being used to assess a given variable. By doing so, you may see if the variable is a useful component in your study. Scales are a key concept in data analysis, and it's helpful to have a firm grasp on the various kinds of scales that can be used to quantify different variables. In mathematics, a variable is a term used to describe a quantity that can take on a variety of values. Age, sex, income, and height are all examples of variables that might be used. In order to classify variables into meaningful subsets, nominal measurement scales are employed. Nominal values are expressed by words or labels and cannot be ranked from lowest to highest. As an illustration, the nominal scale can be used to quantify such a variable as preferred color, with possible values including red, blue, and green. The kind of pet, which can take on values like cat, dog, and bird, is another illustration of a nominal variable. Similarly, yes, no, and other binary variables can be treated as nominal variables. Whenever a variable's values may be ranked from lowest to highest, but the gap between the ranks is not uniform, an ordinal measurement scale is utilized. Hence, it is possible to rank the values of an ordinal variable, but not to quantify the differences between the ranks. Ordinal variables include categories like level of education or level of satisfaction. This set of factors can be ranked from least to most significant, although not all of the differences between them are the same. One with a high school diploma may be given more weight than one with a middle school diploma, but the gap between those two groups is not as wide as that between bachelor's degree holders and those with master's degrees. Interval measurement scales are employed whenever it is possible to rank the values of a variable, and the gaps between the ranks are proportional. This ensures that the distance between any two values can be measured consistently, regardless of their location on the scale. Time and temperature are two examples of interval scale variables. The temperature difference between, say, 20 and 30 degrees Celsius is the same as that between, say, 70 and 80 degrees Celsius. In comparison to interval scales, ratio scales have an actual zero value. Hence, a value of 0 indicates an absence of the variable being gauged. Height, weight, and wealth are all examples of variables that can be compared using a ratio scale. Someone with a yearly income of $50,000 is 2 times as well off as someone with a yearly income of $25,000, whereas someone with no income at all is absolutely destitute. In conclusion, analysis techniques for a given variable are heavily dependent on measurement scales, which are crucial to the process. Researchers can make more informed decisions about the appropriate statistical tools and methodologies, as well as more accurately interpret the outcomes of their analysis, provided they have a firm grasp of the many measurement scales at their disposal.